For thousands of years, the moon has been humanity's constant companion. It has inspired myths, guided calendars, influenced tides, and become the destination of some of history's greatest space missions. After decades of exploration, many believed we already understood our nearest celestial neighbor. But recent discoveries suggest the story is far from complete. New lunar missions are revealing that the moon may be much more complex than scientists once imagined. Rather than being a cold, inactive world frozen in time, it appears to preserve valuable clues about the early solar system, and perhaps the future of human space exploration. One of the countries leading this new chapter is China. Its lunar exploration program did not appear overnight. Instead, it has advanced through a carefully planned series of increasingly ambitious missions. First came orbiters that mapped the moon in remarkable detail. Next came successful robotic landings, followed by the first spacecraft to explore the moon's far side, a region permanently hidden from direct view from Earth. Each mission expanded scientific knowledge while testing technologies needed for future exploration. The next major step involved bringing lunar material back to Earth. Collecting samples directly from the moon allows scientists to perform laboratory studies that simply cannot be carried out using instruments aboard spacecraft. Every grain of lunar soil contains information about billions of years of geological history. Recent sample return missions focused attention on one of the most scientifically important regions of the moon, the South Polar area. Unlike the equatorial regions visited during the Apollo era, the lunar South Pole contains deep craters whose floors remain in permanent darkness. Because sunlight never reaches these locations, temperatures stay extremely low, creating conditions where water ice may survive for billions of years. That possibility has transformed the moon from a place of scientific curiosity into a potential destination for long-term human exploration. Water in space is extraordinarily valuable. It can provide drinking water for astronauts, oxygen for breathing, and hydrogen and oxygen that can be converted into rocket fuel. Instead of transporting every kilogram of water from Earth, future explorers may one day use local resources to support permanent lunar operations. Recent investigations have strengthened evidence that hydrogen-rich materials are concentrated within these permanently shadowed regions. Although researchers continue studying the exact distribution and accessibility of these deposits, the growing body of evidence suggests that significant quantities of frozen water may exist beneath the surface. Scientists are also examining unusual mineral compositions collected during these missions. Some analyses indicate that portions of the moon preserve geological materials unlike those sampled during earlier expeditions. These discoveries help researchers better understand how the moon formed, cooled, and evolved over billions of years. Every new sample improves our picture of lunar history. Rather than being completely uniform, the moon appears to contain regions with surprisingly diverse geological characteristics. Researchers are also studying localized magnetic signatures detected in certain areas. Although the moon no longer possesses a global magnetic field like Earth's, these small magnetic anomalies preserve evidence of ancient processes that occurred deep within the moon long ago. Understanding how and why these regions formed may reveal important details about the moon's interior and its early evolution. Each new discovery reminds scientists that even our closest celestial neighbor still contains unanswered questions. And perhaps the greatest discoveries are only beginning. The growing interest in the moon is about far more than scientific research. Around the world, space agencies increasingly view the lunar surface as the logical starting point for humanity's long-term expansion beyond Earth. Compared with Mars, the moon is much closer. A journey takes only a few days instead of many months, communication delays are measured in seconds rather than minutes, and future missions can be supplied far more efficiently. These advantages make the moon an ideal location for developing technologies needed for deeper exploration of the solar system. If accessible water ice can be extracted from the lunar poles, it could dramatically reduce the cost of future missions. Instead of launching all fuel and life support supplies from Earth, astronauts could eventually produce some essential resources directly on the Moon. This concept, known as in situ resource utilization, is becoming one of the most important goals of modern space exploration. Scientists are also interested in materials that may exist within the lunar surface. One frequently discussed example is helium-3, a rare isotope deposited by the solar wind over billions of years. Although helium-3 is often mentioned as a possible future fuel for advanced fusion reactors, practical fusion systems capable of using it do not yet exist. For now, its scientific and potential economic value remains an active area of research. The Moon may also provide opportunities for astronomy unlike anywhere else. Its far side is naturally shielded from Earth's radio interference, making it an exceptional location for future radio telescopes capable of studying the earliest periods of cosmic history. Meanwhile, permanently shadowed craters preserve ancient materials that have remained largely unchanged for billions of years. These frozen regions may contain a record of the solar system's earliest evolution, preserved in conditions unavailable anywhere on Earth. As more countries develop lunar programs, international cooperation and competition are both increasing. NASA's Artemis program aims to return astronauts to the Moon and establish a sustainable human presence, while China and other nations continue expanding their own exploration capabilities. Many experts believe the coming decades will see multiple robotic and human missions focused on science, technology development, and resource exploration. Exactly how future international cooperation will evolve remains uncertain, but one fact is becoming increasingly clear. The Moon is no longer viewed simply as a destination for brief visits. It is increasingly seen as a place where humanity may one day build permanent infrastructure. That could include research stations, power systems, communication networks, resource processing facilities, and eventually habitats supporting astronauts for extended periods. These developments would represent the first lasting human presence beyond Earth. Perhaps the greatest lesson from recent lunar exploration is not that the Moon has suddenly changed. Rather, our understanding of it continues to evolve. Every new mission uncovers details that earlier generations of scientists could not observe, reminding us that even the most familiar worlds can still surprise us. The Moon has circled Earth for more than 4 billion years. Yet after centuries of observation and decades of exploration, it continues to reveal new mysteries. And those discoveries may become the foundation upon which humanity builds its next great era of space exploration.